Welcome to lesson 1 of 3 in this tutorial, covering the topic of power. This is our first video in our series of 3 lessons on the topic of energy transfers. Here are the learning objectives for this session. First, we will look at power, and then we will look at how to calculate it. Here are the AQA specification points for this lesson. Feel free to pause the video now and read through them before we begin. We'll start off by looking at how power transfers in circuit devices. The power of an appliance is the amount of energy it transfers per second. This means it is the rate of energy transfer. Power is measured in watts. 1 watt means that 1 joule of energy is transferred in 1 second, meaning that it's equivalent to 1 joule per second. Now let's look at our next specification point, covering an equation to do with power. We can calculate power in one of 2 ways. First, we'll look at using potential difference and current. Remember, current tells us the rate of movement of charge. Potential difference tells us the energy transferred per unit of charge. Therefore, to find the total energy transferred per second, power, you need to multiply the current by the voltage. Earlier, we saw that power is the rate of energy transfer. It is calculated by multiplying the potential difference by the current, as shown here. Here's the short version that might be better for you to use in an exam. Here are the units for this equation. Most of them should be familiar to you as we covered them in a previous video. Remember, ampere is simply the full version of the word amp. Let's have a go at this practice question. Pause the video now to have a go at this question by yourself. The answer to this question is 2 watts. Let's work through it step by step. First, we need to write out the appropriate equation, which in this case will be P is equal to VI. Now we can substitute in our numbers, so P is equal to 5 volts times 0.4 amps, giving us an answer of 2 watts. You need to round your answers to 1 decimal place in these calculations, or to the nearest whole number. Let's try a different scenario. Pause the video now to attempt this on your own. Let's go through it together. As always, we need to write out the appropriate equation. Again, it is P is equal to VI. Now we can put in our numbers. So here we would put in 6 volts times 3 amps. This leaves us with an answer of 18 watts. Now let's look at another equation for power. We can also calculate power using current and resistance. We could use this equation, P equals IV. If we don't know the voltage, but we know the resistance and the current, we can still work out the power. We could do this using the equation V equals IR. We can substitute IR in the place of V, as shown here. This gives us P equals IRI, or P equals I squared R. As before, power is the rate of energy transfer. This is our second equation we've just learned. Power is equal to current squared multiplied by resistance. The short form is much more manageable for AQA exams. The units are shown here. Let's try a practice exam question. Pause the video now to have a go at it yourself before we explain it step by step. The answer is 57.5 ohms. Let's write out the appropriate equation first. In this case, the appropriate equation would be P is equal to I squared R. We need to rearrange this to give us R is equal to P divided by I squared. Now that we've rearranged our equation, we can simply substitute in our numbers. So here we would do 920 watts divided by 4 squared. This is equal to 920 divided by 16, which gives us an answer of 57.5 ohms. We've now covered all the learning objectives for this lesson. Feel free to pause the video now and re-watch any of the sections you feel unsure about. We've now completed Lesson 1.